Welcome back. This is going to be a bit of a shorter video here. We're talking about graphing lines. We just talked about slope, and now we're going to talk about graphing lines specifically in slope-intercept form. Notice it has the word slope in there, so we've got our segue for slope. We have talked about intercepts. We've talked about x-intercepts and y-intercepts. This specifically that we're going to talk about today is the y-intercept. All right, so slope-intercept form is this form that I have circled in blue here. You'll want to write that down. Y equals mx plus b. Hopefully it looks familiar. Y equals mx plus b is slope-intercept form. It still has a y in it. It still has an x in it. M and b are just numbers. They can be positive, they can be negative, but they're just regular numbers, real numbers. M in this equation is the slope. B is the y-intercept, and when we talked about a y-intercept, it is a point. So really it is the point 0, comma b. That's 0 on the x-axis and b on the y-axis. So a lot of times we'll just say the y-intercept is b, right? Just the number. So an example of this right here is in y equals mx plus b form. Even though there's a minus, it's okay. What we want to identify is what is the slope and what is the y-intercept. If we just line it up, y equals 3x minus 1. Y equals mx plus b. We want to identify the slope. I said in the last video that m identifies the slope. So our slope is 3. B is the y-intercept. So our y-intercept here, y-intercept is the point 0, negative 1. If that was a positive number, it'd be positive. Since it's negative, we have a negative 1. In this line, y equals negative 2.7x plus 5. We can again just line it up. Y equals mx plus b. We want it to be in that order. Y equals mx plus b so we can identify things easier. It's going to make it much easier when we go to graph. So here, our slope is negative 2.7. Notice those are both with the x. It's the item with the x. And our b, our y-intercept, is the point 0, 5. All right, one more example here. Y equals 4x. Y equals 4x. Does that look like y equals mx plus b? Notice we're missing something here. We do have our m. This is easy. Our slope is 4. But what is our b? Our y-intercept. Since there's nothing there, this is the same thing as plus 0. So our y-intercept is the point 0, 0. If there's nothing here, if there's just a gap there, then our y-intercept is 0. Using those two pieces of information, the slope and the y-intercept, we can graph a line. You remember 2 lessons ago we were talking about graphing with points. Any 2 points will make a line. You can graph 2 points. Well, what we're going to do when we're graphing with y equals mx plus b, slope-intercept form, we're going to graph our y-intercept, the point, right? That is a point. Since we need another point to make the line, we're going to use our slope to find the other point. We're going to move that amount. Remember, slope is a rise over a run. We have a lot of things, ideas sort of coming together here. We're going to go rise over run, find that other point, dot it, and that's going to make our line, our second point for our line. All right, given the equation, negative 5x minus 2y equals 6. First, write the equation in slope-intercept form. So we want it to look like y equals mx plus b. If it ever says write it in slope-intercept form, that's equivalent to saying what we really want to do is solve for y. We want to get y by itself. If you need a refresher on this, you can go back to the video about solving literal equations. Solving literal equations means we have more than one variable and we're trying to get one of them by themselves. That's exactly what we're trying to do here. So in our equation, I'm just going to rewrite it over here. Negative 5x minus 2y equals 6. I want to solve for y. I want y by itself. That way I can have slope-intercept form. The first thing I'm going to do, I'm not going to move the y because I'm trying to solve for it. I'm going to add the 5x. The 5x and the 6 are not enough alike to combine, so I'm just going to call that 5x plus 6. You may intuitively want to write 6 plus 5x, but I'm thinking ahead. Since I want it to be y equals mx plus b, I'm going to have the x thing first. The next thing, to get y by itself, I can divide by negative 2. I'm going to divide everything by negative 2. That gives me y equals negative 5 over 2x minus 3. Notice that is in the form y equals mx plus b. That's slope-intercept form. That answers question A. Question B, identify the slope and the y-intercept. So if we look at this for question B, the slope, m, is negative 5 over 2. The y-intercept, b, is the point 0, negative 3. And if we were to graph that, if we wanted to graph that, I would start at the y-intercept. We're always going to start with the y-intercept, 0, negative 3. That's here. Then we're going to use the slope to find our next point. So m equals negative 5 over 2. I need to go down 1, 2, 3, 4, 5 over 1, 2. Remember, that's a rise over run. I'm rising negative 5. That means I'm going down 5. And I'm running 2. This is always a rise over run. I apologize. My neighbor just decided to start cutting the grass right now. All right, same idea. We want to graph this equation using the slope and the y-intercept. The good news is our equation is already in slope-intercept form. It's already in the form y equals mx plus b. So all we need to do is identify our slope and our y-intercept and use those things to graph. I'll use different colors here so that it makes it a little bit easier for you to see what I'm doing. The slope is this item. The slope is negative 5 over 2. The y-intercept is negative 3. So the y-intercept is the point 0, negative 3. And if I want to use that information to graph this line, I'm going to start with the y-intercept always. I'm going to start with that point 0, negative 3. And then I'm going to use my slope to get to the next point. So I'm going to go, remember this is rise over run. So I'm going to go from there down 5 over 2. I'm going to rise negative 1, 2, 3, 4, 5 and run 2. That gets me my next point, and that's the line that we wanted to graph. I'm just now realizing this is actually the same exact line that we just graphed here, isn't it? It's the same as that line that we just graphed. All right, graph the equation y equals 4x. The question is it in slope-intercept form? Y equals mx plus b. It looks to be. Our slope here is 4. And our y-intercept, remember back that our y-intercept, if it's plus 0, our y-intercept is just the point 0, 0. And so when I get ready to graph this, I'm going to start at the point 0, 0. That means left, right, 0, up, down, 0. Since my slope is 4, and that's rise over run, that's the same thing as 4 over 1, right? 4 over 1, rise over run. It may help you to write it out this way, 4 over 1. So I need to rise 1, 2, 3, 4, and run 1. That gets me to that point. We're doing it all in one swoop. Rise 4, run 1, and there's our line. Determine if lines are parallel, perpendicular, or neither. All right, this sort of goes back to that last lesson. For two lines to be parallel, they need to have the same slope. So for these two lines right here, are they parallel, perpendicular, or neither? The top one, m, y equals mx plus b, m is 3. This one, y equals mx plus b, m equals 3. These two lines are parallel. For the next little set of lines here, for the top line, m equals 3 over 2. Remember, I'm just looking at y equals mx plus b. Here, m equals 2 over 3. They're certainly not the same, so they're not parallel. They are reciprocals, but they're not opposite sign. One's not positive and one negative. So these are actually neither parallel nor perpendicular. They're not either parallel or perpendicular. They're neither. If this had been a negative, they would have been perpendicular. Or if the top one had been a negative, they would have been perpendicular. They have to have the opposite sign to be perpendicular. All right, last slide here. I want you to try the same thing. Notice that these are not in slope-intercept form. So if we want to know if they're parallel, perpendicular, or neither, we really need them in slope-intercept form first. To get them in slope-intercept form, we need to solve for y. So for this line right here, x minus 3y equals negative 9. First, I'm going to subtract the x. Negative 3y equals negative x minus 9. Then I'm going to divide by the negative 3. And I'll get y equals 1/3 x plus 3. The slope here is 1/3. That's the piece of information I need. I'll do my L1 in black. I'll do my L2 in blue. 3x equals negative y plus 4. Since I want it to be y equals mx plus b, I think this is going to be more intuitive if we can just move things around so that it's in that order. We add y plus 3x equals 4. We subtract 3x, y equals negative 3x plus 4. Now it's in y equals mx plus b form. We can tell that our m equals negative 3. All right, comparing these two slopes here. The negative 3 and the positive 1/3 are opposites and reciprocals, so these two lines are perpendicular. I'll pick two more colors here. For L1, if it's just a x equals a line, remember last class, 2 classes ago actually, we talked about if it's just x equals, there's no y involved at all. This line right here is going to be vertical. That means the slope is undefined. X equals 2. I'm going to go ahead and put that on this graph here just so that we can see what happens. X equals 2. All right, 2y equals 8. 2y equals 8. That's the same thing as y equals 4 if we divide by 2 on both sides. We have just a y and no x. This is going to be a horizontal line. And our slope here is 0. Y equals 4 looks like this. Y equals 4 looks like that. Are these lines parallel, perpendicular, or neither? They're certainly not parallel because they're not going in the same direction. Do they make a right angle? And they do. Any vertical and horizontal line, if you have a vertical line and a horizontal line, they are perpendicular. These two lines are perpendicular. They have the opposite slope. A slope of 0 is always going to be perpendicular to a slope of undefined, and vice versa. A slope of undefined is always the same as a slope of 0. We can think about them as fractions. Remember, with a horizontal slope, with a slope of 0, we always had 0 over a number. And with a vertical line, with an undefined slope, we always had a number over 0 to get that undefined value. That's the end of this lesson. Go back and rewatch this as many times as you feel necessary until you're comfortable graphing lines and getting lines into slope-intercept form.